Hello everyone, welcome back to my another video on the Monstack series. I believe this is the episode 6. So on this video we will be scaling up our Node.js application on our backend server, and we'll be working on to wrap up the backend services so that we can move on to UI portion. So without further ado, let's get started on today's video. So as we have completed all of the routes and authentication and authorization, now the only thing left to do on our application is to make sure our application makes use of the CPUs which are available on the server itself. So we'll be working on that one. We'll be using Node.js cluster module to do that. There are other libraries like PM2, which is really cool. So if you guys once you guys get the hang of like what we're going to be doing today, you guys can try the PM2, so that way it's more like approachable, or like it's a more preferred approach for large scale application. But for now, for our application, the cluster module should be good enough. So what we're going to be doing here is we will try to create a blocking code on one of our routes, which will be get to root route, and try to scale that up so that like if we get multiple requests, and even if we have a blocking code, our code will run seamlessly without any troubles for the users. So I have opened bunch of tabs to fetch the to-dos here. All they do is just give me the to-dos from a Foods account basically. So I have 4 tabs opened up. As you can see, it works just fine, right? Like our response time is 80 milliseconds. So we will try to make it worse. Make it worse, by what do I mean by that is in terms of the response time, and we will try to improve it. So what I'm going to do is I'm going to go to the get todos function that we have on todos.controller.js file, and what I'll do here is I'll declare a variable called n, and I'm just gonna provide a bunch like a large number here, because what we'll be doing is we will be looping over, and so that like it takes some time for our server to process the data. I'm going to declare a variable called count, which is going to equal to 0, and I'm going to use a regular for loop. Let I equals to 0, I is less than or equal to n, and I plus plus. And over here, the only thing that I'll do is to count plus equals to I. No, we're not doing anything here. It's just adding this up, something up. You can just leave it blank if you want. I just put something over here so that it doesn't look awkward. So now what should happen is if I go to get todos route, as soon as we fall onto this controller function, this code will take some time to run. That's why what will happen is like this code won't get executed until this is done, because this is not asynchronous, or this is not a callback. It will block our code. Let's try to run that. As you can see, earlier it was 80 milliseconds. Now as you can see, this like we're just sending like it's taking a bunch of time. And the other worst part is if I run the other request again, so this is the real world use case, right, where your users might be sending out requests from different places at the same time. But as you can see, it just gets stuck there. I will give a few seconds just to make sure if we can get the response back. Looks like I'm not gonna get any response back, huh? Maybe I provided like a really large number. So while we wait for this request to go through, what I'm going to do is I'm going to go to index.js file, and this is where we will create our worker processes. So I want to give you the high level overview of how JavaScript works. So basically on JavaScript is a single threaded application. So let's say if your code got stuck here, then it's just going to get stuck, because there's no other processes to like process other like subsequent requests. So what we need to do is we need to be careful about like how we are using our processes. So there is a processes called master process. So right now everything is running on master, but there is a concept called cluster in Node.js which you can use, where you can fork the worker processes out of the master. Basically, it will depend on like what kind of machine you are using. So let's say if you're using a machine with 4 cores, you should be making the use of 4 cores out of that machine. So right now we are only running it on 1 core. Let's see if any of the requests got through or not. Nope, this is really bad. All right, I don't think I don't see a point to like wait here for these processes to like just to go through. So what I'm going to do is I'm going to start writing the code so that we can start scaling our application, right? So now on the index.js file, what you want to do is you want to import the cluster, and we're gonna require it, and it's gonna come from cluster module. CLUSTER cluster module. So you don't have to install this. It comes by default from Node.js. All right. Now, in order to figure out how many worker threads to use, we need to know what's the available number of CPUs right on the specific server, because we can't put the static value like 5 or 4, because that might change depending upon where you decide to host your application. So we want to have the ability to generate the number of CPUs dynamically so that it works on all of the scenarios. So I'm just going to declare a new variable called total CPUs equals to require, and we're going to use the Node.js module again, which is the OS modules. This is the operating system module that comes from Node.js, and there is a function called CPUs, and this will give me the CPU for the specific machine, and you can just use the length property, and that will give you how many number of CPUs that are available. All right, now before we over here, from here to here, right, these are all the import statement and configs. Over here we're actually doing some work for our application. So what I want to do is right after this line 8, I'm gonna have an if statement here to decide whether to fork the worker processes or not. So what I can do is I can just have a simple if statement here. Since we use this cluster right here, I'm gonna copy that, and there is a property called is master, and inside that we will try to create a new process out of master. So all we are doing is check the cluster module that we imported and check if the current processes is a master or not. Master is the main thread, and here if it is a master, then I'm just going to do console log so that it looks good visually and you will know what is going on. And I will just do number of CPUs are, I'm going to use a $sign to insert the variable, and I'm just going to do total CPUs. So that will print as soon as this we run here. This will print out the number of CPUs that we have. All right, now I'm just going to do console log again and do the template string again. And in order to know if there are multiple like CPUs running or not, there is a property called PID. We want to know that, because if the PID is different, then we will know for sure that our processes are running on different cores. So the way to extract that is I'm just going to say master and use $sign, and you can grab the process object, and there is a property called PID. So that will give you the exact address of your CPU is running. All right, so that will give me the process ID of the master. Now see, after we do all of the console logging part, now it's about the time to create a new worker thread. So over here, I'm just going to add a comment, I'm just going to create worker threads. So the way to create a worker thread is as we know, like we don't know how many CPUs gonna be on the server, right? So we have to fork based on that. So the easiest way to do it is you can just use simple for loop. This is let I equals to 0. I will be less than total CPUs and I plus plus. And inside here, over here, all I'm doing is let's get the number of CPUs, and I'm gonna loop over that many times, right? Let's say if I had 4 CPUs, then I'll loop over 4 times, and within those 4 times, we will create a worker thread. So the way to create a worker thread is you're just gonna do cluster dot fork, and that's it. So it will, let's say if you had 4 cores, it will fork the cluster and create a worker threads 4 times. Basically, that is what it's doing. And things are not always perfect, so what you want to also do is you want to make sure, let's say if you're for some reason out of your worker threads, so let's say one of the worker threads dies, basically. So what do you want to do? So what you want to do in that case is you want to make sure it creates a new worker thread automatically if that happens. And there is an on function on cluster module that you can use. You just do cluster.on, and you can pass the property called exit, meaning when something dies, and you can pass a callback function. So it takes worker, code, and signal as arguments, and I'm just going to use the arrow function here. And over here, I'm just going to do console.log so that I know which process just died. So I will do template string again, worker, and $, and do worker dot process dot PID died. So that will as soon as something bad happens to one of our, or like some of our worker thread, it will display on the console. And I'm just going to do console log again, same template string. Now let's, oh no, why did I even do this? Oh, I'm sorry guys, let me grab this to the other side. I don't know what was going on. All right, now let's fork another worker. That will tell us on the console saying, all right, now we're about to fork the other processes. All you need to do here is just do cluster dot fork. That's it. So now, since we did the if portion where we created a bunch of worker processes, now one thing left to do is make a use of those processes, right? And the way to do that is you can just have an else block and come back here, and I'm gonna move this code a little bit. Oops, no, it should be one level down. All right, and that should make sure that all of our app will run on the worker thread, not on the master thread itself. So all the master thread is going to do is it will help to create a worker processes out of it. That's the job of a master thread. And now let me recap what we're doing over here. We are using a cluster module from Node.js. Here we are grabbing the total number of CPUs on the specific machine from the OS module from Node.js. On the if statement, we're checking if the current processes is master or the worker. If it's the master, then we're gonna create a bunch of worker threads out of it based on the CPUs available. And once we create that worker thread, we are dealing with, let's say if some reason our worker thread dies, then what we need to do is we need to fork another one, because we don't want to just stay there. Let's say if you had 4 threads, 4 worker processes running, and if 2 of those dies, then we want to handle those 2 use cases, because we want all 4 of those running every single time. And on the else block, as soon as we're done forking, then we're just saying run these processes. Now if okay, it restarted again. Let me show you now. Okay, now I'm gonna run the server. All right, and now what it says is, as you can see on the console, it says total number of CPUs are 8. Right, so I have 8 CPUs that are available, and this is the master is running on this specific PID. And as you can see, our server instances are looking into are running in 8 different places now. They're listening to the same port on 3005, but they are running on 8 different processes. Same, our Mongo instances are connected on 8 different instances, so there are 8 things that are constantly listening. All right, now let's try this again. I'm gonna send it. I'm gonna send it again here. Because I might have to. I think it's just I put like way too much of a number. That's really big number. let me decrease that a little bit so that I don't like waste your guys' time here. Let's make sure all of our processes, Mongos are connected on all processes. I'm gonna go here. Let's send it. All right, as you can see, now we are getting request on 901 millisecond, 867, and it's pretty much the like similar time frame that we have. Okay, let's increase a little bit. 1, 2. So no matter like how big the number is here, now what will happen is, let's say if one request takes 2 minutes, then next request will also only take 2 minutes, and not on top of, because earlier when we didn't have this cluster, if the first request would take 2 minutes, then second request will wait for the first to finish, then you already lost 2 minutes, and that the second request will also take another 2 minutes to process the data. So that way your second request was getting around, like you'd get those request response basically after 4 minutes. And just imagine if there are a bunch of requests stacking on top of each other. Okay, let me send this one again just to do the quick test. All right, let's go here. So this is too much a big number. Let's reduce 1 0. Let's see if that helps. And this is another good example too, like to make sure why like JavaScript makes a use of callback functions. All right, finally we got our request back. It came back in 11 seconds. It came on 10 second, 10 second, and 10 second, which is quite close. So that's what we want. So, which is good. So what I'm gonna do is I'm just I don't gonna have this code here. I'll just comment this code out so that if you guys need a reference, you can rely on this. I'm just gonna say, here, uncomment to load test. So this is what I'm going to put so that you guys know what code to uncomment basically. Okay, I was like, why it was taking so much time? Okay, it was one thing. All right, I think we're good here. Yeah, that's pretty much it. Like in terms of scaling up your Node.js application. I hope it provided you some sort of value. And now we are done with our backend actually. Now on the next video, we will be moving on to the React portion and start implementing these APIs on our front end. So if you guys enjoy the video, I would recommend to give a thumbs up to the video, which will help me a lot. And if you want to see more of these contents in the future, please subscribe to the channel, and I'll catch you guys in the next video. Thanks.